This is lecture 16 digital circuits. In this lecture, I'm going to discuss about the logic gates. First, we will discuss why we need to study about these logic gates. Now, if I take any digital system, this digital system takes input as digital and it will operate with those digital input and it will provide some digital outputs. Now, what are the different types of operations it will perform, right? So whatever the operation, it may be addition, it may be subtraction, it may be multiplication, and whatever. So we need to identify those operations using the Boolean functions that we already discussed, right? Now, once we know the operations corresponding Boolean functions, now we need some hardware, right? So suppose you know the operations, or who will do those operations? So ultimately a component, a device should do those operations. Now, once we know the Boolean functions or Boolean expressions or logic expressions, now how to implement those logic functions like a hardware? Now that operation is performed by the logic gates, right? So that is the reason why we need to study the logic gates, right? Now first we will see some basic definitions. So logic gates are fundamental building blocks of digital system, right? Whatever the small system or whatever the larger system, or whatever you write, or whatever the Boolean functions you write, ultimately we have to implement using the logic gates. So these are the logic gates are the fundamental building blocks of digital system. Now, why the name comes logic gate? Why not different name, right? Because these logic gates will operate on some logics, right? So the name logic gate is derived from the ability of such a device to make decisions, right? So depending on the inputs combinations, it will take some decision and it will provide some output, right? So depending on some logics only, it will provide the output. Anyway, that I will tell you what is this logics behind these gates, right? That is the name comes logic gate, right? And based on some switching operations also, the name comes as a gate, right? So it's a switching, there will be a switch, so switch can be closed or open. So based on that and based on the decision, so it will the name comes as a logic gate. Now Boolean functions are expressed in terms of that this we have seen already in Boolean function. So any Boolean function can be expressed by either and or not operations, right? Now how to implement these Boolean functions? So that is comes the logic gates. So these Boolean functions are implemented by the logic gates. Now how to implement, right? What are these different types of gates that we have to study, right? So this is about some basic introduction about the logic gates, why we need to study, etc. Now before we discuss about logic gates, so we have to discuss about the logic levels, right? Or different types of logic system. It may be positive logic system or negative logic system. Now in digital domain or digital systems, we'll only deal with either 0 or 1, right? So pure digital means only two values, that's 0 and 1. Now whereas in analog signals, see, this is like an analog signal and this is a digital signal. In students' minds, some confusion will be there. That is, so see, this is also varying, or this is like a continuous signal. So it is either continuous or analog, right? But actually, this is a digital signal because some period of time we are giving a constant voltage, which is 5 volt. So this can be considered simply high voltage, and for the next period of time, it will be 0 or low voltage, right? So this will be fixed for infinite amount of times, right? Suppose this is 5 seconds, then 5 seconds and 5 seconds. This is fixed, right? So, but when we convert pure digital domain, so these levels or voltage levels should be converted into the logic levels, right? So either logic 0 or logic 1, only two values will be there, right? Whereas in analog signal, so it always varies, right? And you cannot assume this is like a 5 volt or this is like a minus 5 volt. So always it is varying. But as far as this one, it is not varying, it is fixed. So this is a analog signal or continuous signal, and this is a digital signal, not digital values or logic values, right? Now we are converting into these logic levels. Now we'll see what are the different types of logic systems are available. So we'll have two different types, that is positive logic system, negative logic system. In positive logic system, suppose this is a signal and it is considering 0 volt and 5 volt, which is continuously repeating. Now what is the logic level we need to assign? So for the low value or 0 value, this is the signal value, this is the logic value. For 0 volt or simply low, we will assign logic 0, and for the 5 volt we will assign high or logic 1, right? Now so this may be 5 volts, is maybe 6 volt, 12 volts, so depending on the type of analog systems or type of the digital system we have, or depending on the technology, so it may be 1 volt also, right? So but generally we'll consider 0 and 5 volts. Now this is 0 volts or low, so logic 0, 5 volt high or 1, logic 1. Whereas in negative logic system, so the opposite. So if signal value is 0 volt or low, but logic value we will assign as 1, and if it is a 5 volt or high, we will assign logic 0, right? See, we can use the both this positive logic system or negative logic system. There is no. So if we use negative logic system or positive logic system, I don't think so any betterment will be there. But as far as the what do you call, the exam point of view, they may ask either positive logic or negative logic, right? Specifically if they are asking negative logic, so we have to apply the negative logic. If nothing is mentioned, it is a positive logic system only, right? So whatever the operations are doing in the positive logic, so it will be opposite in negative logic. Suppose if this is AND operation in positive logic, we make it OR operation in negative logic. So anyway, that we have to see when we discuss about the logic gates, right? So that is about the logic levels and how to assign the logic values, right? Now we'll see what are the types of gates, then one by one we'll see. In this lecture we will discuss only the basic gates. Next lecture we'll discuss universal gates, then we'll discuss the XOR gate and XNOR gate, special gates. Now the basic gates or basic operations we always will consider as AND, OR and NOT operations, or NOT gates in this case, right? And universal gates are called NAND and NOR. Why these gates are universal gates, etc., we'll discuss later. And there are two special gates are there, exclusive OR gate and exclusive NOR gate, that also we will discuss. So these are some classification of the gates. First we will discuss the AND gate. Now what is the source of this AND gate is, or what is the, now we'll discuss the AND gate first. Now what is the reason behind this AND function, etc.? So we'll have to discuss. Now we'll discuss the first AND gate. Now we'll discuss the AND gate first. See, I said all gates are behind some logic. It will operate with some logic. Now we'll discuss AND gate. Now when we discussed about this logic gates, what is why the name comes, so it will depend on some logic, right? So what is the logic in AND gate is, suppose, say this logic came from the switching functions actually. Suppose if we are having two switches are in series, something like this, and there is a bulb at the end and there is a supply. Now what is the logic behind this to glow this bulb? Suppose this switch is A and this switch is B, right? When this bulb will go when both switches are closed, yes or no? So when A and B are closed, when A and B are closed, the bulb will glow, yes or no? If either one of the switch is open, the bulb will not glow. So that is the reason behind this AND operation, right? So that is like this. So I will go for this like this. So first we will discuss the logic symbol, right? Always we'll discuss the logic symbol or logic expressions, etc. The logic symbol for this AND gate is something like this, right? So this is fixed. So it will have minimum 2 inputs and only one output, right? So it may be 3 inputs, maybe 4 inputs also we can go. So minimum 2 inputs and only one output. This is the logic symbol. Now we'll have generalized expression. So general expression is there and a logic expression also will be there. So you may only see in the logic expression or Boolean expression, right? So that both I'll discuss. In general expressions, so generally this output y is equal to minimum of a comma b. So whatever the a and b values, so what is the minimum value? That is the output y. So this is indicates the AND function. So but what is the logic expression is y is equal to a into b or a and b. So this is the logic expression or Boolean expression, and this is the general expression. Now we'll see we will discuss about this why it is called like this or like this. Now if I make the functional table of this AND gate, or generally we say truth table. So what is this truth table of this AND function is? So we'll have 2 inputs. So how many combinations we will get? So 2 variables means we'll get two square combinations. So 0 0 0 1 1 0 1 1, right? And if I write in a decimal form, so 0 to 2 power n minus 1. So 0 1 2 3. So 4 combinations we'll get. Now what is the output function or output? Now what is the minimum of 0 comma 0? It is 0 only. Minimum of 0 1 0. Minimum of 1 0 0. Minimum of 1 comma 1 1 only. See here. So minimum, when we apply this general expressions, we are getting like this. Now even if we apply this logic expression, that is this one, this is the logic. When both switches are closed, that means both are on, right? If both are high, the output also high. So that is bulb is glowing. If any one of the switches open, bulb is not glowing. So that is represented by the logic 0. Yes or no? Or we can simply multiply 0 into 0 0, 0 into 1 0, 1 into 0 0, 1 into 1 1, right? So this is about the AND gate. Now this is about the positive logic. So what happens? The same in negative logic. That you can also verify. I will say this one in logic levels. Suppose this is A, B and Y. This is low, low, output is also low. Low, high, output is also low. And high, low, output is low. Both are high, then only output is high. So you can have like this. What is the output? If both inputs are high or inputs are true, then the output also high, right? So anyway, this is not required. Everyone knows that one. So no one will ask you what is the definition or statement of this AND gate, right? Now we'll see in negative logic. So what happens to this truth table? That also very very important. So now we are seeing the negative logic. So A, B and output Y. So negative logic means, so low will become high, or this will become both are 1 1, because we know that in negative logic 0 will become 1, 1 will become 0. Next 0 1, so this will become 1 0. Next what you call 1 0, so this will become 0 1, and the last one is 0 0. See opposite. So we discussed the negative logic systems here. So low means 0, but in negative logic low means 1. So this is a low to high. Now what happens to output? So low, low, both switches are open, so output is also low, 1. So 1 0 1 0 1 1. So both are switches are closed, that means bulb is glowing, so it will be represented by 0. So this is the AND operation in negative logic. So remember this one, right? So this is the AND operation in negative logic. Or it's very simple. This is, it will become high high, and this is high low. This will become low high, and this will become low low. So what is this? Output. This is high 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 and low. This is AB. This is in negative logic system, right? So this is about the AND operation and the truth table, etc. So the next one we'll discuss the second one, OR gate, or simply OR function. So similarly, as we discussed in the AND gate, so it will have some switching function action that is like this. Suppose we are saying we are having some supply V and we are having two parallel switches, something like this, A and P. Now there is a bulb here, right? Now what is the logic to glow this bulb P? Right, simple. If either one of the switch is closed, then the bulb will go because supply is connected to the bulb. So how to represent those logic? So I'm writing like this, AB, and this is the bulb or output I'm considering. This is output Y. So if both switches are open, so bulb will go no. So output is also 0. So one switch is closed, bulb will go. One switch is closed, one switch is open, bulb will go. Both switches are closed, again bulb will go because this will become short circuit. So short circuit parallel with short circuit is simply short circuit. So this is the operation of the truth. Generally we can say this is the truth table, right, or functional table. Now how to represent the logic symbol, etc. we'll discuss. So logic symbol of OR gate, logic symbol. So logic symbol is something like this. So you have to follow. So minimum 2 inputs, only 1 output, right? So what is the general expression in this case? General expression will be there. So general expression in this case is y is equal to maximum of a comma b. So remember this one. And what is the logic expression here is, this is logic expression or Boolean expression. Logic expression, y is equal to a plus b. But remember, this is not a addition operation. This is just a logic. This is like a symbol only, right? Not operation. It is looking like a symbol. So a or b, right? That means maximum of a comma b. Now if I draw the truth table, again 2 variables, so we'll get 4 combination 1 0 1 1. So what is this? Y maximum of 0 0 0 0, maximum of 0 1 1, maximum of 1 0 1, maximum of 1 comma 1 1 only. So this one is in positive logic system, right? So similarly we can go for L, low 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 high, etc. Now same in negative logic, what will happen? Negative logic. Now if you see the AND gate of negative logic, so what is this? What you call? Yeah. Now if you see 1 1 1 0, and if you see this one 0 1 1 1, so what is this? The positive logic OR gate is equal to negative logic AND gate. So that is the very important point. Now positive logic OR gate truth table is equal to negative logic AND gate, right? This is also very important point, just remember. Now we'll see negative logic OR gate. So A, B, and this is Y. So 0 0 will become 1 1. So both switches are open. Output is also what you call bulb will not glow. That means low. Similarly 1 0. So wherever 0 is there, 1. Wherever 1 is there, it will become 0. Similarly this will become 0 1, and this is 0 0. Right? Now see here, see, so 0 0, that means 1 1, so we're getting 1. So whereas 1 0, so what you will get? So this is 1 here, so you'll get 0. This is 0. This is 0. So 0 0 means what? It is high value in negative logic. So this is low, this is high high high. See here, this is low, high high high. So in negative logic, so what is happening? This is like an AND function, right? 0 0 means 0, 0 1 means 0. So I can conclude here, negative logic of R function is equal to positive logic of AND function. Remember this one. So very important, these two. So positive logic R is also equal to negative logic AND gate, and the negative logic of OR gate is equal to positive logic of AND function, right? So this is about these two gates and the symbols, etc. Now we'll see the last one. The third one is NOT gate, or simply we can say inverter, right? Same, when we see the switching function, so if suppose there is a source, and if I place a bulb here, sorry, not bulb, switch, and parallelly if I place a bulb, now when this bulb will go, suppose this is V, and switch, suppose when switch is closed, any current will go through this bulb? No. So bulb will not glow. When switch is open, so bulb is glowing. So what is this operation? So inverter operation, right? When switch is closed, bulb is not glowing. When switch is open, bulb is glowing. So this is like a NOT operation. So what is the logic symbol of this NOT gate is logic symbol. Logic symbol is on a, what do you call, like a triangle with like this, and add some bubble. Generally we say this is a inverting operation, so this is called just a bubble, right? So for a NOT gate, only one input, one output. So this is A and this is Y. So what is Y? So first we will discuss general expression. This is also we'll get. So generally we don't know, will ask what is the general expression, but if you know, that is also good. So Y is equal to, here we'll get R minus 1 minus A, right? So what is this A? The input, digital input, and R is the radix. So we are only discussing with the binary system. So binary system we are dealing with. So R is equal to 2. Now, so this is a general expression. What is a logic expression or a Boolean expression? Boolean expression is nothing but Y is equal to A bar or complement or A dash, right? So these symbols are these denotations we can use, A bar or A dash, A complement. Now, when I go for the truth table, so what is this function value, function table? I will get A. So only one input, so I can get two combinations. What is a Y? Now see, Y is equal to A bar. So 0, what is the complement? 1. But using this expression, will we get or not? That's we'll see. R is equal to here 2 because binary. So 2 minus 1, 1. What is A? A is 0. So what is 1 minus 0? 1 only. Similarly, 1 minus 1, 0. So we'll get the complement. Or you can use this one. A bar means, so in place of 0, we'll get 1. In place of 1, we'll get 0. So these are the basic operations or basic gates in digital system, and OR and NOT gate or inverter. Now using this expression, we can easily implement any logic function, right? Now I will summarize. So Y is equal to A into B. This is AND gate, and Y is equal to A plus B. This is OR gate. Y is equal to simply A complement or any input complement. So this is a NOT gate. Now suppose if I having any suppose AB plus A bar B plus AC, suppose like this. This is a Boolean expression or Boolean function. How to implement this type of logic function? Now we know that this is a AND operation, this is also AND operation, this is also AND operation. Again we are having some OR operation, so we can implement using the basic gates. First we know the AND gate, right? So one AND gate will come, which is A into B like this, then A bar into B. So we know that I can make A bar, so with giving A here, so I will get A bar, then I can give it to the AND gate. So what you will get? A bar B. So we got second also. Now how to get third one? So simple AND gate, A into C, and 3 will goes to the OR gate because this is a OR function, not addition. So 3 inputs S can exist for the OR gate. So AB plus A bar B plus AC. So this is the function Y. So this is how to implement using the basic gates generally. So that is the main aim right? So knowing the operations or logic expression, now how to implement the different logic functions depending on our requirement, right? That is ultimate goal of the subject, how to design, right? Next lecture we'll see the universal gates, right?